All right, everybody, here it is. This is it. This is the commonly asked 6-point questions. We had like 6 lessons leading to this. It's time. I can complete part 4 parallelogram proofs by 1. Proving a parallelogram by proving one of the 5 parallelogram proofs. Using the parallelogram to prove triangles are congruent or similar. So I love the way I lay these notes out right here. This is exactly what you need to do. It's a lot, but this is what you're going to need to do to get these questions correct. 1, you're going to have to prove the parallelogram. We did a lesson on that. You may need to prove sides are parallel using alternate interior angles. We did that. These are your 5 ways to prove a parallelogram. This and this are definitely the 2 most common. 2 pairs of opposite sides congruent, 1 pair of opposite sides congruent and parallel. Maybe you'll see 2 pairs of opposite sides parallel as well. It's possible to see the others, but these are definitely the most common. Once we do that, we use the parallelogram to prove corresponding parts of the triangles are congruent. And you're going to expect, you see it bolded here, expect to prove alternate interior angles are congruent. Once you have the parallelogram, almost definitely you're going to have to prove the alternate interior angles are congruent. From there, again, there's 2 different types. There's congruent triangle proofs and there's similar triangle proofs. If you're proving sides or angles, if the proof is sides or angles, expect to use addition subtraction property. You're almost guaranteed to have to use addition subtraction property. You state the triangles are congruent once you get your 3 things and you use your CP/CTC. If you are asked to prove multiplication, expect to use perpendicular lines. If not that, you're definitely going to be using your alternate interior angles, but really perpendicular lines can come up in either of them. And then we work backwards to similar triangles when we're proving multiplication. That's a separate lesson. So there's a lot of little pieces. I'm going to go over one of the congruent, one of the similar, and from there it's really going to be on you to practice. Do not attempt this lesson until you've mastered all of the prerequisites. I have, so here we go. I know that the first thing I'm going to have to do is prove that it is a parallelogram. So that's going to be my first goal, and usually that's very easy. I'm going to try and write small here so I can actually fit everything on here. Statements, reasons. 1, EH is congruent to OP. Given. All right, it looks like it's already leading me towards that parallelogram. I already have 1 pair of opposite sides congruent. Next is EP is congruent to OH. EP, OH. Okay, there we go. I have my 2 pairs of opposite sides congruent. And usually, yes, on these very challenging 6-point questions, the parallelograms would be very simple to prove. You may need to use alternate interior angles to prove parallel. In this case, you didn't. But other than that, it's going to be pretty in your face. So now that I have 2 pairs of opposite sides congruent, my first goal was to prove the parallelogram. So now I can say that hope is a parallelogram. Parallelogram has 2 pairs of opposite sides congruent. That just was a little too messy for me. Of opposite sides congruent. All right, so now that I have the parallelogram, we're going to use the parallelogram to get corresponding parts of my triangles. Expect to prove alternate interior angles are congruent. Let's pause and just identify what triangles we're going to be proving are congruent. Ultimately, I want TG congruent to YJ. So TG is a side of this triangle, and YJ is a side of this triangle. So that way I can see at least what I want. So I'm looking for alternate interior angles. So I'm going to look for my transversal. There's my transversal. And boom, There are my alternate interior angles. 1, 2, to make it easy. And I can state that angle 1 is congruent to angle 2. A parallelogram has parallel lines cut by a transversal which form congruent alternate interior angles. We did a whole lesson just on this, just on given it's a parallelogram, proving congruent alternate interior angles. So right now I have one pair of things congruent in those triangles. I'm looking at the parallelogram. I don't see any other properties of the parallelogram that are going to help in those triangles, at least at this point. So now let's move on to the next given. So I'm done with this. I'm done with this. I've got EJOG. EJ is congruent to OG. Given. Now EJ and OG, that's part of what I want. When I have part of what I want, that's when I use addition or subtraction. I have too much. I need to get rid of something, so I'm going to use subtraction. It's almost always reflexive. What do I need to get rid of to get the side that I want? GJ and GJ. So now I start my subtraction process. I need to subtract GJ and GJ. The reason for that is reflexive property. And then ultimately I can state what I want. I want EG and I want OJ. I'm not going to put like all the millions of dashes there. I'm just going to kind of use colors here. So I want EG is congruent to OJ, but I have to show the subtraction, so I write or, and it's basically you're just subtracting what you see right here, that and that, if that helps. Just gotta get rid of it though, but so it's EJ, oops, or EJ minus GJ equals OG minus GJ. And that is subtraction property. And again, you're almost guaranteed to have to do addition or subtraction property if you're proving triangles are congruent on the geometry regions. So this whole thing counts as one thing. So now I have two pairs of things congruent in that triangle. Now I move on to my next given. It says that TG and YJ are perpendicular to diagonal EO. So I'm going to write, let's go back to blue here. Yeah, this thing is just takes up a lot of space. So I got TG and YJ. TG is perpendicular to EO. And I've got YJ, EO. Given. So now I do a mini proof of that. Perpendicular, expect to see perpendicular. Perpendicular lines form congruent right angles. So I'm looking for TJ and EO. Well, this is the right angle in the triangle formed when those intersect, and this is the other one. So I've got, you can put 3 and 4 in there. I don't know how I'm going to fit a little 3 in there. I'm just going to write it out. Angle TGE is congruent to angle YOJ. No, YJO. Now I've got three things. Again, it's a little messy. Can't help that on the computer. I got three things. Once I have three things congruent, I state the triangles are congruent. TGE, YJO, TGE, YJO, TGE, YJO. What did I mark? Well, I marked angle, side, angle. So I have angle, side, angle is congruent to angle, side, angle. And now that the triangles are congruent, I've got TGYJ that they want me to prove. TGYJ. And the reason is CPCTC. So what did I do? I had to prove that it's a parallelogram. That's always what I'm going to do first. It just gave me everything, and I proved the parallelogram. Once I have the parallelogram, you're almost guaranteed to have to prove the alternate interior angles. To find the alternate interior angles, look for your diagonal. It doesn't have to be a diagonal, but it has to be a transversal, a line intersecting the parallel lines. That was it. I was able to carve out angle 1 and angle 2. Then I was given this segment here. That's too much, so I had to use subtraction. Then I was given perpendicular, so I did the mini proof of the perpendicular. Once I had three things, I stated the triangles were congruent. And once I had the triangles congruent, I was able to state the segments they wanted me to prove, CPCTC. If you understand all the prerequisites, it's really not that bad. If you don't understand the prerequisites, then you really can't do this. But it's really just putting a lot of little things together. Now, I'm not saying those little things are easy. Addition, subtraction property is tricky. The rest of them aren't horrible. That's why we did a little individual lessons to go over those first. I know it's a little messy, but keep in mind you have my answer key to refer to that will be a little bit neater. So I said I would go over one of the congruents. Now we're going to go over one of the similars. Let's go over number. I'm just deciding which one I want to do. I'm going to decide quickly. Let's go over number 4. I feel like 4 is a little trickier. We're being asked to prove multiplication. When I'm being asked to prove multiplication, I work backwards. So I've got TA times HA equals HE times TH. Reason, cross products are equal. Keep in mind, if you are not one of my students, maybe you're one of the students that I tutor, your teacher does things a bit differently. You can talk to me about what you want to do, but this is all very sufficient as far as what the Regents cares about. So now that I have my multiplication, I make my proportion. Proportion always, always, always comes before that. Whatever's being multiplied is going to be diagonal from each other. So TAHA, HETH. The reason for the proportion is CSS tip. Before the proportion is always, always, always similar triangles. Is it obvious which triangles I'm proving are similar? You can look at the letters. TAH, HEA, TAH, HEA. It may not be obvious what letters correspond to what, so you can kind of leave it blank for now if you want. And I know that the reason for that is going to be angle, angle is congruent to angle, angle. Now that I worked backwards, I start the proof. I'm going to need to prove two pairs of angles are congruent. I know the first thing I'm going to have to do is prove a parallelogram. So, it's pretty in your face here. HM is congruent to AT. HT is congruent to AM. HM, AT, HT, AM. Do I have one of my 4 pictures? Yup. I can state that math is a parallelogram. I forgot to write my reason for the first thing given. Because a parallelogram has, well, what did I mark? I marked two pairs of opposite sides congruent. Now that I have the parallelogram, step two. Uh-oh, did I freeze? Now that I have the parallelogram, it's getting a little messy here. I'm going to use the parallelogram to prove corresponding parts of triangles are, in this case, are congruent. And again, expect to prove alternate interior angles. So now I'm going to look for alternate interior angles. I can't guarantee this, but it's very likely. There's my transversal, my line hitting my parallel lines. So I'm going to use that to carve out my alternate interior angles in those triangles. There they are. Angle 1 is congruent to angle 2. A parallelogram has parallel lines cut by a transversal which create congruent alternate interior angles. All right, I've got one pair of angles congruent. To prove similar, I need two pairs of angles. So I'm looking for more givens. There we go. I got some perpendiculars. So I'm going to essentially do the same thing that I did in the last problem with the perpendiculars. I'm going to state that HE is perpendicular to MEA, and HA is perpendicular to AT, given. And now I know that perpendicular lines form congruent right angles. The right angles are where those lines intersect. So HE, MEA, that's the one that's in the green triangle. And then HA, AT, there. I'm putting a 3 and a 4. Angle 3 is congruent to angle 4. I've got two pairs of angles. I'm done. Now again, I got to fill in these letters for the triangles. It doesn't matter how I name the first one. So I'm going to go HEA. If I go HEA, what corresponds to H? Well, T does. How do I know that? Well, H is blank in the green triangle, and so is T. So that's kind of why H and T correspond. E is the right angle, A is the right angle, so E and A correspond. A and H correspond because those are the alternate interior angle, so TAH. Kind of look at them, make sure they make sense. HEA and TAH. Yep, looks good. Fill in the rest of the numbers. 7, 7, 8, 8. So again, it's really not that bad if you know how to do all the little pieces. You need to know when you see multiplication, you work backwards. Proportion, CSS tip, multiply CPE. That always is how it ends. You work backwards to the similar triangles. Then you start at the beginning. We know we're going to have to prove a parallelogram. It gave it to us in our face. There's your two pairs of opposite sides congruent. We say it's a parallelogram. And once we have the parallelogram, we know to look for the alternate interior angles, which we found. That was one pair. The second pair of angles came from perpendicular lines, which create congruent alternate interior angles. And you're done. It's really not an impossible lesson if you know all those prerequisite lessons. And if you look back at the notes, there's a lot of prerequisite lessons. It says we have to prove the parallelograms. That's lesson 9. We had a lesson on that. Using alternate interior angles. That was lesson 8. We had a lesson on that. Expect to prove alternate interior angles. We did a lesson on that. We have to use addition subtraction property. We had a lesson on that. We have to be able to prove multiplication. We had a lesson on that. So all those things you need to understand. And once you do, this really isn't undoable. And you're almost guaranteed to see this as a 6-point question on the Regents. If not a 6-pointer or a 4-pointer. So it's important that you spend the time on it. That's it. Practice it. Use my key. Use my resources. Use me. Bye.